just make one more last, at least not last, at least one more expand for the link to the call doc. So welcome everybody to our August CARC systems facing call. We do have a little bit of announcements to share out with the group. And we'll probably drop a note into the Slack that complements this afterwards, but we'd like to kind of announce and welcome Matt Smith, who's been on our steering committee for some time. Matt is going to start stepping into the role of one of the core coordinators as Betsy Hillary kind of winds down and is going to step back out from that role. So thank you, Matt, for being willing to help us out. We will be sending out, I don't know, within the next month or two, probably the next month, I would think, kind of a solicitation for volunteers who might be willing to join us on our steering committee and help us kind of keep the content broad and diverse and hitting all the interesting topics of the community and help us with the organization. So if you're at all interested in that, watch for that, or feel free to just poke any of us in advance as well. We're happy to take volunteers anytime. With that, I will turn things over to Matt to introduce today's call topic and to get us moving.
Great. Thanks, Brian. Really appreciate it. So today I'm delighted to introduce two speakers that will be talking today on cluster management, providing an overview of the tools they use. I'm really excited. We have two experts in the field and frankly, leaders in the world of research computing. So first off, to kick it off, we have John Hanks with the Chan Zuckerberg BioHub, who's going to speak to us today on leveraging Werewolf for cluster management. Please take it away, John.
All right, let me see if I can get my screen shared here. All right, did that work?
Yep. We see it in the, there you go. It looks like you're going to presentation. Yep, that's good.
Okay, sweet. All right, presentations aren't my thing, so I'm sure I'm going to flipping through these slides quite a bit. So just bear with me there. And anybody that has a question, just feel free to interrupt me and ask a question along the way, or at the end. Doesn't matter. I'm typically better at answering questions than I am at just offering up information. So questions may be your best bet. I'm titling this Breaking the Werewolf Warranty for Fun and Profit, because my use of Werewolf deviates quite a bit from what the people who write Werewolf expected people to do with Werewolf. And I'm using, at this point, Werewolf 4. Now I'll get into more details on the things I do to it. Also, I work at Chan Zuckerberg BioHub. They're kind enough to employ me, but that does not mean they endorse or agree with anything I'm about to say. We'll go so far as to say they tolerate my opinions rather than agree with them. All right, I want to start by just getting some semantics down. This has come up a couple of times in the Werewolf development meetings. We've talked about it, that talking about nodes as diskless or disful or stateless or stateful, that's really no longer adequate to describe what people are doing to provision clusters and provision environments. So I'm going to use terms that I'm going to define here as for the operating system install, I'm going to either call it volatile, which means that there's going to be a fresh OS install and configuration at every reboot, or non-volatile, which means any configuration change made on the node when you reboot the node, specifically for the operating system, it's going to come back as it was before you rebooted. And even that distinction is probably not fine-grained enough to address some of the things that we do to nodes. And then for node configuration, I'm going to break that down into two categories. One is idempotent, and that means that every time you apply the configuration for whatever you're configuring, you write a completely new config that blows away all history and just dumps a new working config. Or corrective. corrective would look at the existing config and try to somehow modify or change that config to reach some known working state. In the past, I've used config managers way back to CF Engine, and I've used Puppet, Chef. I've looked at Ansible. I played with SaltStack for a while, and all these tools. And the one thing that I've learned from those tools is that nobody is smart enough to do this corrective and get it right consistently. So I avoid corrective configuration at every possible turn and try to make all my configurations idempotent so that I can rerun the configuration over and over again. Whatever process configures something, I can rerun it over and over, and it'll always do the right thing regardless of what was there when I started. For volatile operating systems, I wanted to include a few examples. Network delivery and install of a common OS image is what we typically do for clustering. People that are doing what we used to call stateless, but we're now calling volatile. You boot the node from the network interface, and then some combination of these network technologies get together and place an OS image onto the node, and the node starts that image through usually by a switch route into a RAM image or whatever. But you get your image from the network. Another example of this that we use a lot that I don't really think about as being a volatile operating system is the local delivery of the OS image, where the node boots from disk, but it boots a copy of the OS image from disk that is read-only on that disk. It never gets modified. And then the read-write configuration of that device is mounted either in a separate location in the file system or an overlay file system for the OS, however they might do it. And this shows up in switches, routers, pretty much anything that a vendor supplies. They will probably use a method like this so that it makes it easy to upgrade the device and safe to upgrade the device, because you can stack multiple images on the node or on the device and fall back to an old image if a new image doesn't work. So we're all familiar with that. And then the live CD images, these always load from read-only copy and use whatever techniques the given live CD uses to give you the ability to write to the operating system or to write changes. Non-volatile operating system examples. This is basically anything that you do an install on that you're going to reboot, maybe your laptop or whatever. And specifically to the cluster environment, the management host must be non-volatile to solve your chicken and egg problem for getting nodes provisioned. So somewhere in the environment, there has to be something that will come back the way it was after a power outage and remember all of its state so that it can provision the rest of the environment. This is a key critical part of any basically volatile provisioning solution that you're going to use for a cluster. In my opinion, there should be no other examples of non-volatile operating system installed. Everything should be stateless. But the real world steps in, and unfortunately, there are snowflakes scattered all over the place where it's just impossible or at least very difficult to get those things to be completely stateless. So Werewolf 4, if you're not using Werewolf 4, if you're familiar with Werewolf 3, an older version of Werewolf, Werewolf 4 made some pretty significant design changes. The number one that causes the most questions from people who are switching to Werewolf 4 is that Werewolf 4 is a volatile OS provisioner by design. It has no built-in anything for provisioning to disk or doing any kind of diskful install. It assumes that everything is going to be volatile and stateless. The network delivery of the OS image is based on containers. This is effectively just a rebranding of what we used to call the VNFS or the Chroot. Same exact thing. The only real change there is that Werewolf 4 wraps a lot of the container provisioning toolkits to manage this, which improves your ability to manage your VNFS or change root quite a bit. But there's really no need to call them containers. You just have to use Aptana or some other tools to pull images. And then there's work in progress to solve the provisioning to disk thing. Enough people have requested it that it's being discussed, and we're trying to figure out some way to work on allowing people to install to disk using Werewolf 4. but that's probably at least several minor releases away, and maybe even that's a Werewolf 5 question. The way Werewolf 4 works, pre-boot, you get the image before on the master, before anything else starts. That raw container VNFS is wrapped up into an initRD. That's basically a CPIO image. Each one of the overlays that Werewolf uses to configure the node, the templates. I probably should have included something in here about overlays, but I'm going to talk about them more later. Each one of the overlays is built for each node. So the raw container is built once for all nodes, and everybody gets that raw container image. Then Werewolf builds overlays that include node specific configuration for every node that's configured in Werewolf. That container and those overlay images are then delivered to the node via currently an IPXE, although there's some work being done to use Grub to do this. Those get delivered to the node, and IPXE, if you've never dug into the internals of IPXE, it's pretty fascinating the way this works. You can keep passing IPXE initRD images all day long, and then tell it to use initRD.magic when it passes that argument to the kernel, and IPXE will stack all those images together. The CPIO format basically allows you to just cat CPIO images one after the other into a single file, and they'll still work as a CPIO image. And so IPXE and the kernel take advantage of this, and you can just keep merging in initRDs to your heart's content. Then the kernel unpacks and mounts the initRD into a TempFS or RAMFS, depending on the parameters it was given, starts the init process, and things proceed from there. And I probably should, there's a little bit of nuance here too, because initRD can extract the images that are passed to it and merge those extracted images, or it can just pass the images through to the kernel, and the kernel can unpack and extract those images. There's a little bit of a problem there in that, as far as I can tell, the kernel, at least in Rocky 8, uses a 32-bit int in part of its CPIO extraction process. So if you give the kernel an initRD larger than 4 gigabytes, bad things happen and your node doesn't boot. And in that case, you pretty much have to have IPXE do that extraction and pass the kernel an extracted file or an extracted memory location with all the stuff in it. Post boot, by default, if you follow all the quick start instructions for Werewolf and get your node booted, the WW client will be running on that node, and it will pull updated overlays I believe by default every minute. Time maybe 5 minutes, but I think by default it's every minute. And this provides a very elegant solution. The entire concept of overlays and just having your configuration delivered as a CPIO archive is a very elegant solution that lets you do some really complex stuff. Now, when I upgraded Werewolf 4 and started using this, did not see this coming, how powerful this whole idea of overlays was going to be. But I'm using it now for effectively 100% of my configuration, and you don't have to add very many features to the idea of the overlays to really do some really powerful configuration tricks when setting up a node. Okay, so this slide, I'm going to talk about what I like about Werewolf 4. And so the main thing that I really, really like about Werewolf 4 is the community. It has a really great community behind it. A lot of people using Werewolf 4 contribute back to the community in discussions on Slack or with tickets back to Werewolf or improvements to Werewolf with PRs. So it's really nice to have that community backing behind it. CIQ offers a paid support option, which we at BioHub do pay CIQ for Rocky and Werewolf support. And it's nice that we can, if all else fails, we can just punt our Werewolf or Rocky problems to CIQ and they'll figure it out. There may be other companies out there that offer paid support options for these free tools as well. Werewolf 4, again, really elegant merging of the provisioning and the configuration of a node so that you don't need any external tools to do any configuration on the node. Everything can just happen directly from Werewolf and the Werewolf config. The overlays, if we manage to add some additional features to overlays and get things like pre and post update hooks and a few other things into overlay configuration, they're really going to be completely offer you the option of completely eliminating other configuration management tools and just having it be pushed from your provisioning master. This point cannot be overemphasized. Easy to work with flat YAML config file. There's no database behind it. There's no extra complexity. There's just a YAML config file that you can open up and edit, read, do whatever you want to, modify it. Easy to pull into other tools. If you want to extract something from the Werewolf config to use with another tool, just, YAML.load, work with your dictionary in Python, whatever you want to do. And then this is not necessarily specific to provisioning a cluster, but because Werewolf 4 includes this nice templating feature in the IPXE scripts that it serves to nodes, it kind of becomes a tool that with a little bit of work in the script templates, you could manage a complete IPXE boot environment. We could, instead of just provisioning a node, Werewolf would happily send a script to IPXE to provide a boot menu from fail-safe boot options, live CDs, pretty much anything that you can deliver over the network. You could manage the delivery of that through Werewolf with these IPXE scripts, script templates. Okay, what I don't like about Werewolf 4. Werewolf 4 is written in Go, and the ideology that everything is going to be lumped into one giant Go binary is absolutely crippling to the stuff I'm listing here. Rapid testing development, you cannot do that when you're editing this massive Go code base where a change on one thing or for one feature might break a bunch of other features as a side effect. This blocks users from contributing code. I'm a firm believer that if you're building a tool for sysadmins, you should build it in a language and a development methodology that sysadmins can do. And I'm going to go out on a limb here and say not every sysadmin wants to be a very adept Go developer or even C developer or any other tool. Like, we do bash scripting and we dabble in Python or Ruby or something, but we don't have time to become, full-fledged developers. And fixing bugs is difficult. The entire code base is super difficult to navigate. If you want to debug something, you got to first figure out how to fix it in Go. Then you have to do a full build install cycle to test your changes. It's just really kludgy to try to fix a bug when you run into a bug in Werewolf. The split of overlays in the system versus runtime. This is something you won't really run into until you're using Werewolf, but the overlays, Werewolf divides system and runtime overlays based on the idea of, is the WW client process going to update the thing after it boots? And if the answer is no, you call it a system overlay. If the answer is yes, you call it a runtime overlay. There's no reason for that. The overlays themselves should have some config flag associated with them that says update or don't update, and then WW client should use that rather than having this arbitrary confusing split in the provisioning process. This bullet is one that I think is super important. Suffers from an identity crisis. The Werewolf 4 project never answers the question, is Werewolf 4 a bare metal provisioner that will take any container you throw at it and boot that container onto a node? Or is this a cluster management solution that's going to manage all aspects of an HPC cluster up to and including possibly in the future managing the scheduler like some other commercial products do? There are some design things inside Werewolf where right now inside Werewolf 4, and I mentioned KMOS.image and syncing UID GIDs, where if your provisioned image does not closely match your master, say OS version, same kernel, same active kernel that you're going to use on the node, if they don't match, things break. So there's an implicit tie at the moment between the version of the OS that you install on your master and what you're going to provision. And if you break that implied tie, it becomes really difficult to get containers to work. You know, there's a lot more effort and complexity and problems down the road. And then being a generic bare metal provisioner, that's a hugely different problem to solve than being a homogeneous cluster management tool. So the Werewolf project could really benefit by deciding which one of these things it's going to do, and then focusing on that thing and eliminating the stuff from the other one. And then the last point, bloat. There's absolutely no need for your provisioner to manage your NFS exports. There's no need for it to provide an SSH wrapper. There are many other better tools for this, Clutch, PDSH, you know, pick your poison. Other people have already solved these problems. Managing IPMI devices, that is a vendor specific support nightmare. There's no reason to try to wrap that into a tool. Any tool that does these things, and again, I'm thinking of another commercial tool that I also don't like. Any tool that tries to manage everything under the sun ends up building in a bunch of arbitrary boundaries that limit the scope of what you can do with that tool. So for me, I would like to see Werewolf 4 more focus on just provisioning, just deliver the overlays, and then get out of the way and let the sysadmin decide what tool they're going to use to SSH to the nodes, or, you know, do whatever downstream things they're going to do with the nodes once they're running.
That's a good question there, John.
Oh, what's the question?
So with kind of how you described it being a fantastic community, right, and very collaborative, in regards to these critiques that you had, do you see from the developers, the community, a receptiveness? I'm not super familiar with the community, so I'm just fishing for understanding. If you and a lot of other people are expressing these similar concerns, does that seem to affect the direction that development is going? Do we see it incorporated in to achieve improvements to address these things?
So I would say I'm probably the only, or maybe the most vocal user in the specific things that I want to see Werewolf change in. And to that extent, I'm backing that up as I can with PRs that implement or fix things that I care about. There are some other people who have some overlap with some of the things I do, especially around overlays. There are people in the community that we have Slack conversations going on about improving the overlay handling. So I think the features that I would like to have in around overlays probably are more toward helping the community, and there is community support about that, and everybody involved in development is, you know, doing what they can. People work on the things that they care about, right? That's the way open source works. But yeah, receptive, yeah. I don't think that the Werewolf project is going to break itself just to match what I want it to do, right? So my expectations are realistic, and I understand that some of the stuff I do is pretty far out there relative to what Werewolf is designed or oriented towards doing. And I understand I broke the warranty, so in that case, I'm going to fix it if there's a problem.
Thanks.
This is what my current HPC environment is doing. And in my view, the ideal environment end to end would have the absolute minimum sysadmin effort input to produce the maximum complexity and best user environment possible. And I really stress hard minimum sysadmin input, because as kind of like a moral position, I do not like large IT organizations and large groups. I think the problem we're solving here, in my view, is not that hard of a problem, but you can make it hard if you hire enough people. So I'd like to focus a lot of my effort on how do I simplify this environment and keep it as simple as possible and don't let it get out of control. And so to that end, I want all my hosts to be stateless. I don't want to have an OS install on disk that survives a reboot anywhere in my environment. I'm about 95% there. I have a handful of snowflakes that run as VMs and a handful of workstations that I don't have physical control over, where I can't provision them statelessly yet, but over time, those things are being picked at and moved out of those stateful environments or non-volatile environments and into a completely network provisioned environment and managed environment. The one container to rule them all, success there. We have one node image, and that node image does everything in our environment from basic node to workstation, full desktop node, web server, ZFS NAS storage server, everything that we do, login node, it all comes from a single node image that then the configuration forks post boot via the overlays to become whatever that node needs to become to live out its life. All network interfaces routes configured by DHCP. Every node in my environment except the management host, which have to be able to survive a reboot to provision everything else. Everything is 100% configured via DHCP. There are no IF config files out there that have IP addresses in them. Those have been eliminated. All host names and lookups handled by DNS. Again, 100% solved. And we get, by doing this, we get a lot of stuff for free as a side effect. For instance, the nodes have multiple networks. Almost every host in this environment is multi-homed. And if I want a node, say I want a node to use InfiniBand for all of its communications, then all I have to do is tell that node to use the InfiniBand address as the name server on my DNS mass name servers. And they will, by default, return the best address for that InfiniBand network. So all of the internode communications will then switch to InfiniBand simply by pointing at the right name server and using the same host names. And everything will just work. There's nothing, there's no additional configuration to use. And that's been a huge win to have everything just work based on the name server that the name lookup goes against. All user group info pulled from a single source of truth. We do that by Active Directory, and that also is a huge win to know for sure that UID, GID information is going to be consistent on anything that is in the environment, anything that gets touched by users. And those three bullets together solve a problem that I didn't mention before that I also don't like about Werewolf, but it's not Werewolf specific necessarily. I think if you're passing around password files, group files, or ///hosts, then your environment is broken. Like these, passing those around as files, it just shouldn't be done. That opens up all kinds of ways for nodes to drift out of config and cause problems downstream that require way more effort to fix than it takes to run a stable, useful, reliable DHCP DNS environment, especially with the availability of DNS Mask, which is super simple to use, easy to set up redundant name servers and DHCP servers. The thing just works. All node configuration managed via overlays. I'm about 99% here. Before I had enough skills with the Go templating and learn my way around systemd well enough to get everything into overlays, there were some changes that got into the container that I haven't quite rolled out and moved into overlays yet, but I'm very close to having the entire node configuration done via overlay. And I guess I should say that's the volatile configuration that comes from the Werewolf server. Some nodes do maintain local state through a local file system. An example of that might be a web server where there will be a local ZFS file system that will mount it /HTTPD and it's var live or var www, because that stuff is that specific to that node that doesn't get sent from the central config. And also we have ZFS NAS servers, which clearly have many, many petabytes of data stored locally on disk, although the operating system is configured and provisioned from Werewolf. All configuration and revision control, pretty close on this one too. I I would say 100%, except that I'm scared I would be lying because there's something that I've forgotten about. But I'm very close to having the entire configuration of the entire environment in revision control, which means effectively my laptop, I can do an SVN update and a git pull, and I have a complete backup of my entire infrastructure environment on my laptop or any other host that I go to log in and pull that configuration, pull those repos into. And the last one, all hosts are Slurm nodes. I'm very close on this one as well. The exception list there matches the stateless exception list from the top. And a few hosts that for security reasons, we don't want to participate in the Slurm cluster. This one is important to me because I use Clush to manage the cluster very heavily. And I don't define any node groups or anything in the Clush config directly. My Clush config is entirely derived from Slurm and Werewolf. So I can pull node groups from Werewolf and I can pull node groups from Slurm. And that's how I clush to hosts. I just don't define anything. The second part of that's very important is we use Node Health Check very heavily for monitoring nodes. And having every host in Slurm means I don't have to have a separate tool out there that's monitoring the status of any of my machines. My storage servers, web servers, everything reports into Slurm, and every 5 minutes that health check runs. And so I can look at Slurm to see if my nodes are up or down. And I guess maybe the last thing that's useful for this is I use Slurm very heavily with root jobs for system maintenance and for doing tasks. And it is a stupendous tool for node management from that perspective. Now S-Control Reboot has basically replaced all the former hackery that I had used to try to gracefully reboot nodes. So yeah, having Slurm as a scheduler is great. Having Slurm as a management tool just makes it that much better. And I wanted to go through the things that I do that are not really the approved way to use Werewolf. I build and install from source because building and install from RPM puts things in locations that make it really difficult to use ZFS effectively with this. And one of the ways I use ZFS, which I think I may discuss later on in a little more detail, is because all of my change routes and all of my overlays, everything, and I keep a mirror of all repos that are used in my environment for installing packages. Because those are all in ZFS file systems, whenever I do an upgrade of our image, I can snapshot those file systems, do the upgrade, test it. If it doesn't work, I just roll back and throw away all those changes. If I really want to do something hardcore with that testing, which I'm probably gonna have to do in the future, I would snapshot all that stuff, clone it, update my DNF config, yum config to point at the clones for the image, and then I could test my updates ad infinitum as long as I want to without disturbing my original environment, and roll back forward everything as I needed. When I install, I run the development branch in our production cluster, although I really don't believe that there's such a thing as a production HPC cluster. We're all running development, but I do run the development branch at Werewolf 4 as a daily driver. When I install Werewolf, I effectively do the sed to just disable every feature of Werewolf again. Most of this stuff is just bloat. Werewolf shouldn't be doing it. There are better ways to do it than trying to roll it into the same tool that you're using to send images to your node. I abandoned the default WWNet overlay and the generic overlays that are included with Werewolf, and I do not use WW Client as an update tool to keep the node in sync. We do all the overlay updates via a push process where we trigger it. We don't have it just happen automatically. I use the bus-based device naming. I don't use the ETH0 or friendly names for devices. We use the device based on whatever UDEV gives it for the bus name. I use systemd as the init at boot, so there's no no switch or pivot root in the process of provisioning for us. We just boot straight systemd right off the tempfs that was the init RD with no changes. I've broken the overlays out into one overlay per service or per thing. I'm gonna say thing because it's sometimes it's kind of fuzzy. Configured by that overlay. I have an overlay for SSSD, for SSHD, for Crony, for multipath. Each one of those gets its own overlay.
Hey, John, sorry to interrupt your
Yeah.
flow here. My sincere apologies. However, we do need to transition to the next speaker at some point within the
Oh.
next couple of minutes to allow for time.
Oh yeah, sorry, my clock. I have no clock on my screen because I'm full screen for the
Yeah,
presentation.
no worries.
No idea how much time is it.
Yeah, you have about 1 or 2 minutes left.
Okay. Yeah, this is almost the last slide, I think. And the rest of those, these are just things that I've done. Probably the most important one is the local wrappers there. There are a lot of aspects of Werewolf where there are bugs or other problems that I need to work around in our local environment. So I'm producing a lot of little wrappers that fix those things. Future directions, basically just want to keep improving and get all those previous numbers to 100%. The most important thing on this slide probably is that last one. I'm trying my best to generalize our overlay collection so that anybody using Werewolf could just grab one of our Werewolf overlays and drop it into their configuration. I have a few at that site. There's a Crony and one for Munge. The goal being that people don't have to reinvent the wheel every time they want to configure Munge. They could just grab our overlay, drop it into their setup, and it would work for them. And that's it.
Awesome. Thanks so much, John. Really appreciate it. In the essence of time, we are going to roll right into Gary's talk. I just request that everybody who has questions for John to please enter them into the chat. And we'll do our best to capture them in the call doc. And then if we happen to have time at the end of the call, we'll open it up for discussion. But without further ado, we'll hand it over to Gary Skousen, who will be speaking to XCAT.
Oh, you're muted, maybe.
Thanks, Roberta.
Sorry about that. Yeah, I'm Gary Skousen. I'm going to talk a little bit about how we use XCAT. I work at the Institute for Computational and Data Sciences at Penn State. So if you're interested in looking, there's lots of documentation. You should find it on Google pretty easy. Our end goal when we tried to set up our cluster is we want to operate the system as a system, not as a pile of hardware. Even though it's a pile of hardware and software, you want to manage it as a system. And then our next goal was to have infrastructure as code. Everything should be in Git, and we should manage and track changes to everything. So that was our goal, and that's mostly where we are. There are a few caveats of things we did to try to make that work. As far as operating as a system, one thing that was important to us was the node discovery, which is great when you set up a cluster, but it's also important when nodes fail. So in our case, we use a network-based discovery based on where the node sits in the topology of the network. That dictates what its host name is and what its IP address is. And so when the node boots up, there's a discovery process, finds out where it is in the network, and then collects the MAC address and uses that for DHCP or PXE boot. While XCAT does, by default, will set up a DNS server. We'll set up bind on your local XCAT master. It does have provision if you want to set up communication between your XCAT master and your site DNS. You don't have to use XCAT's DNS. And in that way, XCAT's pretty modular. While it comes by default with a lot of bits, you don't have to use any of them if you don't want to. In our case, we use most of the stock XCAT. It also provides remote console, power control, system event logs, stuff like that. It provides tools for parallel copy, although I tend to use PDish just because that's what I've been using for 30 years. So, but console logs are great, especially if you end up with a system crash and it's a stateless node. It's great to be able to see what's on the console. And while you might be able to use like an iDRAC or something, a lot of times the piece that you want has already scrolled off the screen. And so the console logs have been critical for debugging. In our setup, we manage a lot of different hardware types. We have everything from Ivy Bridge to Sapphire Rapids, multiple GPU types, multiple interconnect types, which don't all necessarily talk to each other. We have multiple Ethernet connections, some bonded, some not, some with multiple homes, which need specific routing configurations for them. We have hardware from multiple vendors, including Dell and HPE. And so it was important to us to have something that would work with all the different equipment we have. And then we have kind of a purpose of our nodes that we manage with SCAD is kind of a mess. We have the normal compute nodes, login nodes, batch scheduler, VPN server, monitoring stuff like Graphite, Jenkins, license servers, Globus, endpoints, Open on Demand, Open Science Grid endpoints, GPFS quorum nodes. All that's managed with XCAD. And so to do this, we do very close to what John talked about. We try to be mostly stateless. Obviously, as he pointed out, your provisioning server can't be stateless. But by and large, most of the rest of them, I say stateless in that every time we boot, they boot a new OS, and things like varlog, we usually put that on disk, and we have the temp file system is a disk. So while the nodes have disks in them, the OS isn't on those disks. It mostly just mounts those for volatile things. There are things that's not true, like Slurm DVD. We have the database on disk, but again, we back that up regularly with a database dump. And so to some extent, it's not critical. We could rebuild a Slurm DVD from any random node we happen to have. Similar with like an OpenVPN config or other things. There are nodes with state information that we keep, but by and large, everything when it boots stateless. XCAD also provides options for different OS images. I've done RHEL 6, 7, 8. We haven't tried 9. We're looking at that. You can do Rocky. It doesn't have to stick with x86. I know if you do IBM Power, you can get the Power 9 LE Red Hat to boot with XCAD also. We've been strictly x86, 64 stuff. So the OS image that you boot is basically a kernel and an initRD and then a compressed image file. And we save those get built in a particular directory. Having those image files collected as artifacts means that if we have an outage and things go wrong, we can always fall back to what worked the previous day because it's all there. But our goal was to reproduce everything from code. So in XCAT, there's a command called genImage pack image that generates your image. And every time the node boots, it boots that image. While the XCAT management node is installed to disk, we actually use XCAT to provision our management server. So from the current management server, we provision a new management server. We then can shut off the current one, move the IP address, and bring up the new one, and everything's back to normal. And so that's kind of our way of making sure that our infrastructure is all code. Everything's in Git or actually XCAT uses a database. And so that, again, we back that up. We actually dump the tables and put those in a Git repo so we can tell what changed. And so we can actually roll back to a previous database configuration because that's in Git also. XCAT image options, there's a list of things that go into an image. There's a list of packages you install, like just the RPMs that would be installed. We use package lists. We've modularized them, so we have kind of some basic stuff that goes everywhere. Obviously, we don't have GPUs in every node, so we have a separate package list that has the packages we need on GPUs with the right say NVIDIA drivers. The OFED stuff goes only on nodes that have Mellanox cards in them. And so we kind of have a list of packages a list of package lists. And then as far as XCAT goes in provisioning, everything I've done CF Engine, and back in the day of AFS, they had their overlay stuff, and I've done Chef and Puppet and Ansible, and they all have their pros and cons. In this case, everybody knows how to do Bash, and we standardize on the XCAT post install. So all the configuration scripts we use, most of them are Bash. There are a few that we've written in Python or other things, but mostly just Bash scripts. The post install happens at image creation time, so there's some things you may want to provision when you build the image, like setting a munge key or something that you want to be common throughout everywhere. Other things happen at boot time, which you kind of need to know what the IP address in that. So GPFS MMSDR restore has to happen at boot time. We can't put that into the common image. We actually, when we boot up, we provision everything with a dynamic IP address. Once they boot, they set a static address. I've had problems in the past with DHCP servers getting stormed since you boot your whole cluster within a short period of time, and all the DHCP requests tend to time out about the same time. And occasionally DHCP isn't really generous with how, because it's partly due to the protocol. It's a broadcast protocol. And so the renewals didn't always happen. So we, by default, set static IP addresses everywhere. Those are also, while they're provisioned by DHCP, the IP address is static once the host is up. XCAT also provides options for kind of overlay files for like an SSSD config or something that you want to be common. It also provides hooks in its sync list for node specific things. If you want a specific file, like if you're doing two-factor authentication, you may not want to do that on all the compute nodes, but you might want to do it on, say, login nodes. And so having a sync list that's slightly different for different types of nodes makes that kind of helpful. And then the configurations for the BMC, the IPMI or iDRAC or whatever you want to call it, is all part of the XCAT config. Most of the configs does not require that you put in a line for every node. It has some fairly robust scripting. If you're used to doing sed, search and replace, some of their node configuration things are done kind of like that. So you can set an IP address range for nodes based on the host name. And similar for the BMC, it all kind of pivots off the node names. And then the package locations, that's another thing that's important. So you can have different package locations for different images. Obviously, if you're running some RHEL 8, some RHEL 9, you'll need a different package list or where your repos are for those. We also keep local copies of all our repositories we use. We sync them from the internet, and then we have a snapshotting file system where we'll snapshot, and all our production nodes get built from a snapshot. And so when we decide we want to roll a package forward, we use a different snapshot. And so we update the snapshots, but we want to make sure that things don't accidentally move on us. So yeah, my goal is reproducibility and making sure we can roll back if something bad happens. Having been bitten by a few all-nighters trying to figure out what went wrong. So image definitions are a combination of the sync files, the package files, the post installs, post scripts, package source locations, and it's all kind of defined in a definitions for the OS image. Like I said, we use a whole bunch of different node types. Some of them are kind of a hierarchy. So we might have a basic compute node, and then we'll have a basic compute node with IB, without IB, with GPU, without GPU, maybe with IB and with GPU. And so you kind of can define your hierarchy based on what your node types are. And like I said, everything we have in our cluster, Open On Demand, VPN server, Slurm CTL, Slurm DVD, it's all provisioned by XCAT based on these configurations. We put everything in Git. So all our package list, sync list, PostScripts, everything is in a Git repo. And XCAT expects all of its scripts to be under a certain tree. We put a few symlinks to point to where our Git is. And we have a cron job on the XCAT master that every minute it pulls everything from Git and overwrites whatever's on the local disk. So if a sysadmin decides they want to temporarily change something, they can, but it only lasts for a minute. And then it's back to whatever you get. We have our convention is that whoever makes the pull request shouldn't merge it. There are definitely exceptions. If it's 2 a.m. and you're trying to get something up, you may not want to wait for somebody else to come online, but our default, we post to a Slack channel saying, hey, we want to make a change. This is what it is. And then people can review it and complain about it, which they sometimes do, or find typos, which is great. But like I said, everything goes through Git. And then we heavily use the stuff from XCAT, and we could certainly split out things like DNS or how we PXE boot, or in our case, it was easiest to set it up based on the stock stuff that came with XCAT. We have a bunch of pieces that we maintain and Git, and there are definitely drawbacks to that because it's hard to prototype. We do have a test system. We have you can set up XCAT in a simple VirtualBox environment, assuming you have enough memory. But our goal is everything installs as code, so we can wipe our system and be back and running from our Git repo. We do not manage our ESS nodes from IBM because they want to do it their way. We obviously don't manage it. We have some vast storage. We don't manage that through XCAT, but then again, that's kind of a black box. And so there are some things we don't manage that way, but by and large, all the nodes that we manage are managed through XCAT. So this is definitely not just me that worked these things out. That takes effort from a big team here at Penn State. There's actually a talk given at the HPC SysPros workshop last year by Ross Mickens about some of that. You can go look that up if you want. A lot of this work stems from stuff that I worked on with some guys at the Environmental Molecular Sciences Lab at PNNL. There's a talk by Ken Schmidt and Evan Felix at the SysPros conference in 19. So you can go look up that talk if you're interested. There's a GitHub repo that kind of lays out the whole plan of kind of how we do things. You can check out the MSIL MSC cluster management GitHub if you want for more information. And that's it.
Amazing. Thank you so much, Gary. That was super insightful. So now we open it up for questions for both John and Gary. So if we can ask folks to ideally unmute, name the institution or place of work or a unit that you're most associated with that you feel you're representing, and then specify who you're directing your question to or to both. There's also the option of typing your question into the chat if you don't have access, or would prefer not to come over audio. And then we, as the hosts, will do our best to ask the question on your behalf. Who's going to be first up to ask a question?
All right, I have a question. Oh, sorry, Paolo
Yeah.
raised his hand before me, though. Did you see that? Paolo has his hand raised.
Hey Gary, so you mentioned using Puppet, trying Puppet in Chef and Ansible. Why didn't it work out, and what were you using those tools for?
So I've used CF Engine and Chef and Puppet and Ansible, and mostly they work really good at doing specific tasks that you want them to do. They do very poorly, as was pointed out. Keeping a system to look exactly like you want it to look, none of the tools do a very good job at that. They all expect you to know what you want to do, and it does a really good job of doing something, but keeping it. I mean, unless you could specify every file in your system in your Puppet or your Chef config, it's only going to mess with the files you tell it about.
Right.
In HPC, I wanted all my systems to look exactly the same, and you can get close if you. We did it for a while back on an old system. We used to kickstart all the nodes when we brought them up, and so we'd start fresh every outage with a fresh kickstart and install the disk. But over the course of the next weeks, things would drift. Either you push out a change, and you hoped you got it, or the Puppet script you ran expected it to be in one state, and because it was in a different state, it didn't know you wanted to also, there was a conflict, when you do a yum install, and it didn't resolve the conflict for you. So I don't discount how those work, but also Puppet and Chef and all those, they don't do the remote power control. They don't, I mean, you can write Chef and Puppet to do that, but they don't do the provisioning. They don't do, and so it seemed easier. Plus all of those, I really am not a big fan of Ruby. So all the guys on my team know how to do Bash, and XCAT made it easy that we just do Bash.
Yeah, I would totally second all of that, and maybe add a little seasoning. You can do everything with Puppet and Chef and other tools like that they are designed and won't let you do, but you can do anything with a Bash script.
Awesome, great answers.
Thank
So,
you.
Thank you for the question, Alan. Next up, Janet. Where are
Yeah, I
you?
was just gonna ask if you're running different OSs on any of your clusters, like, are you doing, do you have two different distros that you could boot on the nodes? And if you do, how are you handling that?
So we have done, I've done switches between, like say Rel 6 and 7, 7 and 8, and you can make a split cluster and basically you build different images. So on XCAT, there's a simple command node set that tells the XCAT which image you want to boot on a node. And so if you have 3 different images, you could do node set and tell it to boot one image, and tomorrow do a different node set and it'll boot a
No.
different image.
No, I understand that. My question is, how do you build those images? How do you handle that?
So yeah, so normally there is some difficulty with trying to build a newer image. Like if you're building Red Hat 8, building it from a Red Hat 7 master has some complications. So when I've done it, we upgraded our XCAT master first, and then it will let you build the old image and the new image. You could also set up 2 systems to build the images. But once the image is built and you've got a kernel and an NRD and a compressed CPIO file, you don't actually have to use ones that you built with XCAT. You can use any image.
Yeah.
So we build them with XCAT, but you wouldn't have to. We have
So-
booted like a disk grubbing image that we didn't build.
Yeah, so my experience is the same, right? If you have an external build system, then you could build an image and then you could boot it on your XCAT master. That's basically what you're doing for unless you upgrade the master to what you want to, the new image you want to build.
So
Like-
yeah, when I did it, we had a test cluster that was a hardware cluster, and so we upgraded that one first and built images for the new Red Hat release.
Yeah.
But we haven't tried Red Hat 9, but that's our next goal.
Okay, thank you.
Yeah, so I've got a question that stems from the recent Red Hat debacle. So it put me in mind of something I've been thinking about for a long time, and I think other people have also. What can we do to minimize our dependence on the operating system? Most
We actually
actual
have
packages. No, I mean, to get to the point where the operating system is almost trivially unimportant. You need one, but we don't actually make use of the things that you build operating systems for. If you think about building software in SPAC or EasyBuild, all the things that we used to rely on the operating system provider, we don't go there for them. So what can we do to further trim down our dependence and maybe, optimize the chance of a thing like the community enterprise Linux offerings to succeed?
So to some extent, there's dependencies with how you configure certain things in obviously Ubuntu. You're going to do apt instead of yum or DNF, but to some extent, as long as they're similar enough, we actually have a Rocky cluster, because the LIGO group, they want all their standardized on Rocky. So while we have a license to run as many Red Hat instances as we want, that particular cluster runs Rocky, and there's really very little change that had to be made to our scripts and our deployment stuff.
That's our experience too.
We pointed at
But
different
I'm asking a
package lists.
different question than that.
But-
I'm basically think of what Alpine is doing. Alpine has basically managed to eliminate its dependence on the GNU stack. And I think we can go that direction. There's a lot of stuff that we do out of convenience because the operating system can do it. But honestly, apart from a few minor things like setting interface addresses and stuff, you don't actually need an operating system to do those things. If we went to a really stripped down, shoot it into the, so Werewolf has this idea at its core, right? You start with a minimal boot and then you add overlays. But I'm thinking, what if we could think through the way that we use worker nodes? Ultimately, what you really want a worker node doing is running an application or a user application. Everything else is kind of unimportant on how you get to there.
I kind of think we're already there to some extent, where you don't care about the operating system. When Red Hat dropped the bomb on us, I immediately went out and started looking at other alternatives. We were running Rocky and Alma everywhere. I looked at OEL. And in the past, I've looked at Devuan because I didn't just want to get away from every other operating system. I wanted to go away from System D as well. And in all those cases, I can make any of them work, right? Even if I do full-fledged desktop installs, I can make any of them work. So if there was an edict that came down from above tomorrow that I had to switch to, pick any operating system, by the end of the next week, I would have my cluster provisioned using NetOS. For me, the bigger thing is, how do I make that work from user space? And in user space, the absolute easiest way for a user to interact with the cluster is to have all the software they need installed so they can just say module load blah, run the thing they want, have a full desktop environment on the node so they can get a desktop and on demand and do whatever they want with a fully featured GNOME or KDE or whatever desktop. And beyond that, it doesn't really matter. The actual distribution we run is Rocky 8, but that could have just been randomly picked, right? I could have ran Ubuntu or Debian or anything that I wanted. And even though we do a full featured desktop on all of our nodes, we also have Apptainer. So at the end of the day, people can bring their own container and do whatever they want on our fully featured desktop, and that all runs now without any extra effort. And they don't need root or sudo or anything to do whatever they want to do on a node. So the actual operating system, I don't really think it matters that much anymore.
Yeah, not everybody as good as you are, John, but and Gary. But let me just put that out for people to think on. And I do think part of the answer that I was looking for is what you said, containers. So then my question reformulates itself as, what's the minimal startup environment to get a container to run? Let's just not bother with the rest of it. And then we won't be as dependent. We'll be more where you are, that, we can swap on a moment's notice. Of course, you have to point out that the vendors are doing everything they can to go in the opposite direction, to make their container environment completely dependent on your choice of operating system and everything. So we just have to resist that and keep this kind of purer mindset in mind, I think.
I think probably the thing about containers is they work great unless your kernel and libc disagree with the container, right? So at the end of the day, you're always going to have to be running at least a kernel and a libc that agree with the containers that you're going to run. And since people can bring their own containers, there's no way I can guarantee I'm going to agree with all the containers out there. It might, if you're going to pursue that line to its logical conclusion, you wouldn't boot your nodes at all until the people told you what container they wanted to run. And then you would boot the node with something that would run that container. And the users would drive the cluster instead of adapting their workflow to the cluster. I'm a big fan of making everything work great for users, but I'm not sure I'm ready to take that step.
All right, sure.
I'm not sure I want to trust every container that the user throws at it either. I'm not sure I want to trust their container.
It seems like there's one other layer that we all potentially have to deal with too, and that would be the specialty things like specialty drivers or special file systems. And the only real point to capture there is just to kind of recognize that some of those things are not as prepared for the bring any distribution, world as it is. You go to Lustre and you'll see a list of supported OSs, and that may not be as broad as you want. So it seems like within our community, there are a few things at the driver, at the file system, and other things like that that you do need to put in at the base layer, that even though a container comes in. So if we can get those people, to become more flexible, then maybe we can hit a better state that you're, trying to help us paint the picture for Alan. And
Sure, the
comments are really
patchless
helpful.
Lustre client was, it's not the most popular choice right now, but that was the thought behind that. And thank you for saying that, because I was going to just bring up that is one of the missing pieces. Let's just finally, I think wrap up all the related topics by pointing out that many items of software that depend on those drivers need to be rebuilt if you change them, right? So
that was a driving thing for our choice of Rocky 8 over Rocky 9 when the current cluster I'm running got built, was that NVIDIA and IBM had a falling out, and there are no GPU drivers for Power 9 for NVIDIA stuff. And we had at the time some in production use nodes that were PowerPC that had V100s in them. And we couldn't run Rocky 9 on those nodes. And since we wanted the environment to be as consistent as possible for users, we went with Rocky 8. Yeah, that kind of thing. And you can expand that into just ISVs in general. Like if you want MATLAB support, you got to run an OS that MATLAB supports. And sprinkle that across ANSYS and all the other commercial tools, Schrodinger, everything else. If you want support, you got to be running on a distro that's supported. So we're kind of at the mercy of the people that are producing the drivers and the packages that users want to use as to what we have to run underneath the covers.
Yeah, really great discussion generated by Alan's question and great answers. Yeah, really appreciate you both speaking to your cluster management tools today, Gary and John, and not just focusing on the positives, but also sharing some of the the dirty laundry that comes with running those solutions. So thank you so much. We're really grateful. And yeah, have a great day, everyone. See you all out there in the ether.